Hello everyone! Welcome to another video in our civil engineering review and refresher. So for this video, the featured topic is about stopping sight distance of both horizontal and vertical curves. Stopping sight distance is defined as the sight distance that is available for the moving vehicle in the highway that will enable the driver to stop the vehicle safely without collision with any other obstacle. So let us have first the sight distance for horizontal curves. So we have two cases here, that is when the sight distance is less than the length of the curve. So if we have a curve here and then this is from PC to PT na. So we have the length L of the curve. By the way, the figure here is assuming that the curve is the center line of the highway curve na. So that is at the center line. So let us say we have here 2 points A and B. So let us say at point A we have here the car, in which the driver can be able to sight an object at B. So this is the sight distance, no? Can be able to sight and also can be able to stop, no? With having B as, or at point B there is an obstacle. Then let us say the line of sight can be obstructed by this structure or whatever obstruction to the line of sight from the driver at A to the object at B. So this distance from the center of the highway curve to this obstruction is M. Then R here is the radius of the circular curve. So we do not derive formulas here, no? But I think the formula here can be easily be derived, no? But in this video, derivation of the formula is omitted. So M is equal to S squared over 8R. So we know already. So M here is this. Then S squared over 8R. So we have here na the notations used in the formula. So M is the clear distance from the center of roadway to the obstruction here. S is the sight distance, L is the length of the curve, and R is the radius of the curve. So problem, a highway curve has a degree of 11.5 and a length of 90 meters. If the required sight distance is 80 meters, how far off the center of the road could you allow the bushes to grow? Okay, so we have here a highway curve na. So the length here is 90 meters. And then the required sight distance is 80 meters na. So how far off from the center of the road could you allow the bushes to grow? So from the center of the road, so we can allow the bushes to grow at this distance M na. So that the driver on the car at A can see the obstacle, or object on the road at B. So, as you notice, the sight distance is 80 and the length of curve is 90. So, S is less than L. So, we can use the formula, no? So, formula for M. So, that is... In our figure here, we do not know R. So from the arc basis, R is 1145.916 over D. So for a degree of curve of 11.5, R is 99.64. Then we can use our formula for M equal to S squared over 8R. So S is 80. Then R, as computed, 99.64. So M here is equal to 8.03 meters. So the second case is when S is greater than L. Na? So if this is our curve, so again, assume this is at the center line of the highway curve. Then we have the radius R. So we have the obstruction. So this is the length of the curve. And then we have here the sight distance S. So from the driver on the car at A to the object at P. And this is the value of M here. So when S is greater than L, as shown in the figure, our formula is M equal to L times the quantity 2S minus L over 8R. Where M is the clear distance from the center of roadway to the obstruction here. S is the sight distance, L is the length of the curve, and R is the radius of the curve. Problem? The clearance to an obstruction is 20 meters and the desirable sight distance when rounding a horizontal curve is 300 meters. Determine the minimum radius of horizontal curve if the length of the curve is 250 meters. So we have this figure, and as you notice from our given, M is 20, na? S, the sight distance is 300 and the length of curve is 250. So we have here S is greater than L. So we can use the formula here. So with the given values, we can compute for our R 547 meters. So as you notice, in this type of problems, mostly direct substitution to the formula. No? So using the formula with one element there is unknown, and that is to be solved. So the second part of this video is the sight distance for vertical curves. Okay. So case 1, that is for summit curves. No? So when S is less than L, so we have here. So let us say we have a summit curve from PC to PT now, or PVC to PVT. Then we have a car now moving on the vertical curve. Then we have the driver's eye here. So the driver's eye is at the height H1 vertically from the road, no, to the driver's eye. Then let us say we have the object here, the obstacle on the highway. So and the height of the obstacle is H2, no? From the surface of the road vertically. Then from PC to PT, we have the length of the curve, and this is the distance S, na? The sight distance S. So when S is less than L, this is given by the formula. So A is squared over 100 times the quantity square root of 2H1 plus square root of 2H2 squared. Where A here is the difference in the gradient, na? G1 minus G2 in percent. So with G1 positive and G2 negative, so we come up here a G1 plus G2 in percent, na? Then the second case is when S is greater than L. So we have a highway curve, no, or vertical curve, no, from PC to PT with the driver or with the car moving on it. So this is H1 and then this is H2. So we have the length of the curve here and then the sight distance, no? So since S is greater than L, our formula becomes this: L equal to 2S minus 200 times the quantity square root of H1 plus H2 quantity squared over A, where A is still the difference in the grades in percent. So, problem 1. A grade ascending at a rate of 4% meets another grade descending at a rate of 5%. Compute the minimum length of vertical curve that will provide 150 meter of stopping sight distance. Assume eye height of 1.5 meters and object height of 0.6 meters. Okay, so we have a summit curve here, na? So this is the vertical curve here from PC to PT, na? So the back tangent has a 4% grade and the forward tangent has a 5% grade, na? So we have here the given na S is 150 meters, na? The stopping sight distance to be provided. Then H1 is 1.5, eye height of the driver. And then H2, the height of the object on the opposite side, 0.6 meters. And then the question is find the minimum length L na of the curve. So G1 4%, G2 is negative 5%. So from our formula, we have this na where S or A is G1 minus G2 na. Okay. So substitution to the formula, we have this. And the result is 253 meters. So if you check, L is greater than S na. So our S is less than L. So we use L equal to 253 meters. Problem number 2. Compute the sight distance of a vertical curve at the intersection of a plus 2.4% grade and a negative 3.6% grade for a length of 120 meters. Assume eye height of 1.5 meter at each end of the sight distance. So meaning we have two cars here no, in which the height of the eyes of the two drivers no, in both ends is 1.5 meters. So we have here na. By the way, we have a car here, then we have also a car here. Or any other height with the height H2 equal to the height of the driver na. Pero possible on this problem, we have a car here, we have also a car here. Na. Parang hindi lang na-edit tong figure natin. Okay. So, the question is the sight distance for a length of a highway for a length of curve of 120 meters. So L is 120. We are asked to solve for S with H1 and H2 equal to 150. So G1 is 2.4, G2 is negative 3.6. So we assume S is greater than L na. So we have this formula. So with L equal to 120, H1, H2, and A are given. So we can substitute values and solving for S, that is 160 meters. So if we check, S is greater than 120. So the sight distance is greater than the length of the curve. So use S equal to 160. By the way, pag magkamali ka sa assumption mo, you will go to the other formula. Automatic yan mag-satisfy. Okay. So that is about stopping sight distance of vertical summit curves. How about for Sag Curves? Okay. So the sight distance of Sag Curve is related to the height of the beam of the vehicle headlamp. And that is a 1 degree upward divergence of the light beam is used in computing the length of the sag vertical curves. Okay. By the way, this is assuming that we have short stopping sight distance for night time compared to daytime na. Kasi daytime nakikita naman lahat na in the sag curves. Okay? So, if we have here the length of the curve na PVC to PVT, then let us say this is the L length. We have the car, and then the beam of light is somewhere here, na? And then for a 1 degree upward divergence, so this is the basis. No? So when this is the figure of the light beam, then the object can be seen if that is within this range. Na? So if the object is at the PT, so visible na yan sa driver, and then we have our stopping sight distance S here. Huh? So we have two cases here. So when S is less than L, L is equal to A squared over 120 plus 3.5 S. And then when S is greater than L, no? So ibahin lang natin yung figure. That is when S is greater than L. L is equal to 2S minus 120 plus 3.5S over A. Okay, problem. Determine the minimum length of a sag vertical curve between a negative 2% and a positive 4% grade for a road with 110 km per hour design speed. The vertical curve must provide 200-meter headlight sight distance. Okay. So, we assume that S is less than L na. So, this is a sag vertical curve na. So, assuming that S is less than L, what are the given? G1, negative 2, G2 is 4. So, our A is the difference na. Then, we have 110. I think hindi natin magagamit to. This will be used for other consideration. Because if the formula for S will fail, na, we have other criteria to be satisfied, na, which is beyond the scope of this video. Na. The vertical curve must provide a 200-meter S, na, and then we are asked to solve for the length. So using the formula, when S is less than L, so L is to be solved. So we have 2. I think nagkamali to, na. So bali 4 minus negative 2. Ano na lang natin to, i-correct na lang natin, ha. Correct na lang, correct, erase na lang, ha. Gamit na lang tayo ng eraser. Bakit hindi? White pala. Dali. White, tapos para madali itong brush. So we have now minus negative 2. So substituting the values, then we can obtain L equal to 293 meters. Okay, so the video is about stopping sight distance both in horizontal curves and vertical curves. So thank you very much. Thank you for viewing my video, no? And I hope my video discussion help you in your studies, no? Especially to my students there in CECC 1. Okay, bye-bye.